Hello dear children and welcome back to the class. Today we are going to learn about the periodic trains in the modern periodic table. So what are the trains in the modern periodic table? Yes? Yeah, there are specific patterns present in the arrangement of elements in the periodic table. Periodic trains are specific patterns that are present in the periodic table that illustrate different aspects of a certain element, including its size and electronic properties. Due to the periodic trains, the unknown properties of any element can be partially known. These trains emerged out of the specific arrangement of elements due to the periodic law. Major periodic trains include valency, atomic size, atomic radii, ionization energy, electronegativity, metallic characters, melting point, and so on. So let's begin with the first periodic trains in the modern periodic table. That is nothing but the valency. So define valency. Dear children, valency is nothing but the combining capacity of the element. Valency is also defined as combining capacity of the atom of an element with the atoms of the other elements in order to acquire 8 electrons. The valency of an element is linked with the electrons already present in its valence shell and the electrons which it actually needs. The atoms having 1, 2, 3 and 4 valence electrons normally lose these to the combining atoms and they show the valency 1, 2, 3 and 4. The atoms having 5, 6 or 7 valence electrons generally take up 3, 2 or 1 electrons respectively from the atoms of other elements and show the valency 3, 2 or 1. All the elements present in a group have the same electronic configuration of their atoms. They have therefore the same valency. For example, all the elements present in group first have the valency equal to 1. All the elements present in group 2 have the valency equal to 2. Dear children, since the elements present in a period do not have the same number of valence electrons, they do not show same valency. In a period, elements have different valencies. For example, the number of valence electrons in sodium is 1. So the valency of sodium is 1. The number of valence electrons present in magnesium is 2. That's why its valency is 2. The number of valence electrons present in the aluminium is 3. That's why its valency is 3. This is all about the valency. Now let's see the second periodic trains in the modern periodic table. Atomic size is nothing but the distance from the center of the nucleus of an isolated atom from the outermost shell containing the electrons is nothing but the atomic size. In our group, atomic size or atomic radius increases downwards. Atomic radius is expressed in the unit picometer, which is smaller than nanometer because 1 picometer is equal to 10 raised to negative 12 meter. Dear children, you will find that the atomic radius goes on decreasing while going from left to right within a period. The reason behind this, while going from left to right within a period, the atomic number increases one by one, meaning the positive charge on the nucleus increases by 1 unit at a time. The additional electron get added to the same outermost shell. Due to the increased nuclear charge, the electrons are pulled towards the nucleus to a greater extent, and thereby the size of the atom decreases. Here you will find that while going down a group, the atomic size goes on increasing. This is because while going down a group, a new shell is added. Therefore, the distance between the outermost electron and the nucleus goes on increasing. As a result of this, the atomic size increases in spite of the increased nuclear charge. This is all about the atomic size. Third periodic trend in the modern periodic table is metallic and non-metallic characters. Dear children, metals are present on the left side as well as in the center of the periodic table. Non-metals are located on the right side of the periodic table. Metalloids constitute some border line elements and are shown by zigzag line. The metallic characters of the element is due to their electron releasing tendency. By losing electrons, metal atoms change to positive ions, that is cations. These are therefore electropositive in nature. Down the group, the metallic character increases because the electrons releasing tendency of the atoms tends to increase. Along a period, the metallic character decreases because the electron releasing tendency of the atoms tends to decrease. Non-metallic characters of the elements is due to their electron accepting tendency. By accepting electrons, non-metal atoms change to negative ions, that is, anions. These are therefore electronegative in nature. Down the group, the non-metallic character decreases because electrons accepting tendency of the atoms tends to decrease due to their increased size. Along a period, the non-metallic character increases because electrons accepting tendency of the atoms tends to increase due to their decreased size. Now let's see the gradation in halogen families. The group 17 contains the members of the halogen families. All of them have the general formula X2. A gradation is observed in their physical state down the group. Thus, fluorine and chlorine are gases. Bromine is a liquid, while iodine is a solid. Now, we studied about the periodic traits in the modern periodic table and the gradation. Alright, I hope so the topics are clear to you. Thank you very much, my dear children.